Hey everybody, it's Rick Usey and it's Tech Tuesday. Today I'm going to be talking about how you can stay productive in a pandemic. I'll be right back. Thanks for joining me and welcome to Tech Tuesday. Again, today what I'm going to be talking about is how to be productive in a pandemic using a proactive network maintenance tool. And I'm going to be showing Pre-Acquisition Analyzer. Some of you may be customers of that, some of you may not be that have that, but this is a good general idea of what you can do with a PNM tool at times like this, because I know a lot of you, a lot of cable operators, this is specifically for DOCSIS cable operators, but I know a lot of you are trying to figure out what you can do if you're a field maintenance technician, or maybe you manage a maintenance group. And could be where maybe you're not going into people's homes as often, maybe only in absolutely necessary conditions. So it's like, what do we do in the meantime? Well, there's a lot you can do. And proactive network maintenance is a great thing to do anytime, because it can really save you a lot of money and outages and issues in the future if you look at things that are going to be causing issues in the future, but maybe right now are not impacting your service. And there's a way you can do that with PNM. So we'll be talking about that. If you're on with us, you can go ahead and chat. If you have any questions or comments, if you're watching us live, please just go ahead and use the little chat feature there on YouTube and let me know that you're watching. And if you have any questions during this time, go ahead and ask those, and I'll do my best to answer them, or I'll get an answer for you in the future if I need to do that. So again, DOCSIS PNM, and I'm going to be showing you Pre-Acquisition Analyzer. So let's jump right into that. Let me make sure this is working right. I'll go ahead and put my little pointer on here so you can see when I scroll around here. I think it's working. Hold on. Yeah, we're looking good. Okay. So this is the main screen on Pre-Acquisition Analyzer, and what you're seeing here you don't normally see. I'm showing you an operator who has been very proactive in their cable plant maintenance. So they use this tool in conjunction with TrueVision, and they go out and they hunt for red modems, basically. And as they do that, they find out what's going on with that device and they correct it. And you can see it's very unusual to see an operator that's got only 16 red modems and this many green modems, 1,521. And what this signifies in a PNM tool, it's not like you would see in a corrective diagnostics application like I showed last week with TrueVision. That corrective diagnostics looks at what's going on right now, and it looks at the RF levels and the power levels, and it tells you, and you can see in the thresholds with different colors, which devices right now are experiencing issues. What a PNM tool does is it looks at the DOCSIS pre-EQ values coming from the CMTS and between the cable modem and the CMTS, where the CMTS is telling the PNM tool, the CMTS is telling the cable modem to adjust its pre-EQ values, basically, in order to compensate for any upstream impairments. So, for example, if there's a bad microreflection between the cable modem and the CMTS will receive the signal from the cable modem. It will tell it how to adjust its equalizers in the device, in the cable modem. And then when the CMTS receives that signal, it looks really good. So it basically tells it to send the inverse on the signal of what it's getting. If you think of the haystack maybe as tilting one way, then it tells the cable modem to transmit, to adjust its equalizer so the haystack is going the other way, and then it looks nice and flat when it comes to the CMTS. And that's great, because you can have issues like microreflections or group delay out in the cable plant, and if that's the case, then everything looks good to the end user because it's being compensated by pre-EQ. And what a PNM tool does is it reads those pre-acquisition coefficients that are coming from the cable modems, between the cable modem and the CMTS, and it can then plot that on a map, and it tells you which devices are compensating for that impairment most. So you can see which ones, the ones that are green, are not having to compensate that much. Your yellow ones are kind of in a warning stage, and then you've got an alert on the reds. And by the way, this is blurry for a reason. I've got this map blurred out because we're actually looking at a real customer here. Unlike TrueVision, where I have a demo set up where I have fake names and addresses and maps, this is a real provider, so I'm trying to not show that. So again, this is what it looks like on somebody who's really doing a lot of proactive network maintenance. So when you were to click on the red modems here, that 16, you'd see that not much shows up. They don't have a lot they can do. I mean, they've got stuff they can do, but they've got a lot less to address here. And I'm going to show you another operator where it looks a little bit more like it does a lot of times. You got a lot of yellow and a lot of red. And again, this doesn't mean that all of these subscribers are having an issue, because they may be perfectly fine because pre-EQ is compensating for those issues. But what this means is that you can now look and see which of those customers or which of those devices are working the hardest to overcome that impairment, because that's only going to be able to take place for so long. Eventually the modem, there's just not enough headroom for it to adjust its levels anymore in order for that modem to stay good as far as it looks to the customer. And eventually these things will go offline, and sometimes it's multiple modems being impacted by the same thing, and then you got multiple people going offline. So that's why it's good to get ahead of this stuff, and why not now when maybe you're looking for things to do because you can't maybe go into as many homes, and maybe you can look at some things in the outside plant. So let's kind of walk through this a little more. Again, I can click the red modems up here, and now I see everything that's red. So this is kind of my target list, but you can also go to the business intelligence dashboard here. This is kind of an overview of the plant, and you can see some things. You could maybe work on a critical modem action list. A lot of times this might be in-home stuff or near-home stuff. You can see your trends over time. You can see again here you've got another look at your red and your yellow and your green modems, and you can scroll down and you've got Spectra Vision or your Spectra impaired modems. That would be your downstream full band capture charts that you can look at. And over here you've got your correlation groups. And I was going to start here. So a correlation group is where the application looks at the pre-EQ values coming in from modems in a similar geographic area, and it says which ones are adjusting them pretty much the same, because they're all compensating for a common impairment. So you can go ahead and click on any of these. When you do, you will come to a map, but then you can click on signature. That's your correlation groups. And then you can select one of these. I went ahead and I selected the first one. And obviously I'm showing slides here again because I can't blur out everything live. So here I'm looking at a correlation group, and you can see pretty quickly that you've got these modems grouped up here. And these are the in-channel frequency response, which I'll expand on here in a minute, for all of these devices on the different frequencies. So you can see that they all are very similar. You got a few that are kind of a little different, and that's most likely due to some in-home or near-home issues in addition to what we're seeing as more of a plant issue. So I've got these charts, and I can click on any one of these. I'm going to go ahead, and when I did this, I clicked on this one here. And you can see this expanded now. This is this one group right here, and you can see all of the devices that are listed. So we are looking at 24.2 as far as the frequency now. That's what I clicked in. And you can look over here, and you've got your outside plant or your VTDR, your virtual TDR in feet. And that's showing you about 335, 330 feet on this VTDR. And what that represents is an echo cavity. It's not a distance from a modem to anywhere. It's a distance of an echo cavity, a microreflection that's taking place somewhere in the plant that all of these devices are being impacted by. So they're all having to send their signal upstream through this microreflection. So that's what we're seeing. And you can, all of these devices right now are all on the same chart. You can select one. I went ahead and selected one here, and you can see just that one by itself. And that one you can see, in addition to having this outside VTDR, it's got a TDR, which is more indicative of an in-home or a near-home problem. In this case, probably, I guess, near-home, because it's 167 feet. And you can see these others, there's a couple that don't have any. So when I selected that one, you can see, oh, I meant to go back. Let me show you. I forgot to mention. So in addition to this, you've got your digital taps over here on the right. And these are basically, think of this like an equalizer, the old equalizers, if you're old enough to remember them like I am. You had maybe an equalizer in your car, and you had different sliders that you could adjust to adjust the signal to suit the room. Well, that's basically what's going on here. The cable modem is adjusting these little slices of frequency so that it fits the conditions of the cable plant better, again, to level out that signal. And right here we're seeing there's a couple of elevated taps. In this case, we've got a very high elevated tap 12, and that's what we're seeing as this VTDR. The further you get out on these taps, the longer the echo cavity is. So right here I'm looking at VTDR of about 330 feet from that. I can tell that from this. And then this one is what's basically making this 167 feet. So this is something a little bit closer to into home. That's also a problem that's compounded on top of this. But we still know that this particular device is part of this group. And then again, if I were to click two of these together now you see this particular device has got a 0 for TDR, and you can see this particular color down here. There's no in-home issue that it's showing right there. It's just got the VTDR right there. And if I were to select another one, then you can see I just overlaid another one. It's a little bit slightly different on this one, and it's got an 84-foot TDR or in-home, near-home echo kind of cavity. And then you've got, again, a very similar one to these others. So these are all experiencing a common impairment here. I'm pretty sure of that. So something else that you want to do as you have this group of devices here, you want to check your, I guess it would be your last good modem, because we're going upstream, right? So you've got your last good modem, and I'm assuming this is upstream. And that could be either one of these. I just happen to check this one. And when I open that one up, you can see it's very different. There's no outside plant VTDR. There's a small here in-home issue. But you can tell from the taps, tap 12 again is not elevated, and everything looks pretty flat right here. So this one seems fine. And I checked the other one as well, and it was very similar. It did not have an issue. So if I expanded this map out here now, I've got my good modems here that are not in the correlation group, and then this one's a little unusual in that I don't have anything else on this down here, but I'm assuming that everything's running this way. I don't know the cable plant. I'm assuming it's running this way. And there's a 300-foot span of cable somewhere where there's an echo bouncing back and forth. It could be from an active, bouncing back at an active. It could be a bend in the cable. Could be a tap or something that's bad, loose or something. So at least you have a distance, and you know that all these devices are being affected by the same thing. And right now, again, these may be, if I were to look at the in-channel frequency response on these post pre-equalization, they probably all look pretty good, pretty flat, but eventually they won't be able to compensate. And then if whatever this impairment is out here gets worse, and it will, right? It always gets worse. It's sitting outside, and it could be getting more corrosion. It could be maybe water's leaking into a crack. Could be some device that's going bad. So it's going to get worse. And when it does, then all of these folks will then have a problem kind of at the same time, because they're all experiencing that same impairment. So that's why it's good to look at these things. So that's one way that you can keep people kind of productive, is to look at this tool, find things like this, these correlation groups, and then go out and you've got a distance, approximately where it is, and see if you can change out some things, find some issues, and you might turn these devices to green and see that you get rid of that correlation group. And that will prevent you from doing a reactive call later, because that's usually what happens, right? When we're all busy, we react. So you wait for a customer to call, or in this case, maybe 5 or 8 customers to call, and then suddenly you react and you go out there and you try to fix it while they're not very happy about it. So you can take care of it in advance. That's what we're trying to do. That's why it's proactive. Something else that you can do is, I brought the main map up here again. When you do that, you can click on the data tab, and what that does is it brings up a table of all of the devices on this particular CMTS. And I went ahead and I sorted that by VTDR, again my outside plant, and I see several very long echo cavities right here. And you can go ahead and click the little green arrow or plus sign there, and that will pull up the device, the details on that device. So I can see that I've got 3 frequencies here, and 2 of them are showing that very similar VTDR, and I've got a little TDR here as well, so I can see that. And then I can double click on that device, and when I do, I bring up the details on that, and I can see right here, before we were seeing an elevated tap 12, in this case I've got tap 22 that's elevated. So again, the further out you go on those taps, the longer the echo cavity is that you've got. So that's why I'm seeing tap 22 elevated here with almost 1,200 feet. Now I noticed again that this particular frequency for some reason doesn't show anything, but it does look like they're all pretty much the same. So you can isolate that, and you can click on, that was 37, where is it? Yeah, 37. So you can click the button, and when you do, I took a screenshot of that, and you can see that it is also lots of ripples here. And if you go out to tap 22, you see while it's not elevated above the threshold, it's very close. That may be why it's not showing up. I'm not sure. I thought it would show up anyway, but it is not as bad as this, for sure, because it's below the line, and these two other were above the line. Now, this is not showing up, by the way, as a correlation group because it's not quite bad enough. We try to not, we don't want to show too many because we don't want you chasing around for stuff that are questionable. This one, I think, is not questionable. There's definitely a problem going on here, and we'll see that because even though it's not a correlation group, I can dig around a little bit and see that there are other devices that are also experiencing this problem. So here's basically my group of devices, and what I did here was I clicked. Let me see if I go back there. Is that back? Yeah. So you can click nearby modems on this device, and when you do, it's going to pull up a map with the nearby modem showing. And the device that is selected, you can see down here. Well, I just covered it up with that, but you can see down here that the one that's got the blue, it's like that going. Yeah, you see, selected CM is down there at the bottom, and the one that's got the blue, it might be hard to see. The blue outline is the modem that you selected. So I can now try modems next to it and see what happens. I tried this one to the left, and it was fine. So I tried the next one, and I saw, you can see it's very similar as far as what you're seeing here. Again, you've got tap 22 elevated. You've got a similar thing where you've got the same kind of VTDR here. And I clicked, I hit nearby modems and I clicked the next one, and I hit nearby modems, that's this one here. And this one you can see is only on one frequency, but again, it's got a lot of ripple here, and it's got an elevated tap 22. So the same thing's going on here. And I click nearby modems and I click the next one. Again, it looks very similar. So we're sure that these are all being impacted by the same thing, elevated tap 22. So basically, I also tried this one, and I tried this one, and basically what I came up with was 4 devices that were all being impacted by the same impairment, about 1,200 feet, give or take 50 feet probably, 1170 give or take 50 feet. And that, again, tells me that I've got an issue that I can maybe address here. So I would have to figure out where I've got a 1,000-foot span of cable where I could have an echo cavity bouncing back and forth that is all of these devices. I would guess it was going off maybe in this direction somehow, because you've got devices here, you've got a device there, you've got devices here and there. So I would assume, I'm not a cable plant expert, and I don't, even if I had a strand map in my hand, which I don't, I couldn't read it, but I can tell from looking at this that I would imagine that it's going off in that direction somewhere, and there's something back here that these are all being impacted by. Again, it's not the distance from the device, it's some span of cable and 2 reflection points where that micro-reflection is going back and forth. So that's another thing that you can look at during these times when maybe you're trying to find something to do. And later, when everybody gets back to work, this is a great thing to do regardless. So it's just something that is especially beneficial right now when you may have some resources idle, and you can use those to go proactively fix things. But we really should be proactively fixing things all the time. That's the best way to go about it, instead of reacting as soon as when something breaks. Your customers will be happier, and you'll be happier because you save a lot of time and money if you do that. You save a lot of truck rolls in the future because you can plan your truck rolls and go fix these things methodically, as opposed to when everything's on fire. A few other things in this tool that can be helpful. Again, if you've got remote workers, you've got an Upstream Analyzer in here. It's an optional feature, so you may, if you've got a license for this, you may not be licensed for Upstream Analyzer, but it's not expensive if you don't have this. It's up under the Analyzer tab, and here I'm looking at a particular upstream coming directly from the CMTS. So this is the upstream passing through the CMTS. I don't need to have anything attached there. All I need is my CMTS in this application, and I can see here's my channel, there's my others that are adjacent to it, and I've got ingress under the carrier turned on. I can actually look at that because we know when the cable modems are transmitting, so we know when it's transmitting and it's not, so we can actually plot a line of ingress here underneath the DOCSIS carrier, so we could tell immediately if there was some issue where there's a lot of noise under this carrier. So this is a great tool to have, again, for being remote. You don't have to go make a trip to the head end where the CMTS is. You can look at the upstream right here. There's also an upstream monitor. I don't have a screenshot of that, but that will look at this over time so that you can kind of scroll back and see what the what it looked like over time. And because this is a screenshot, you can't see that this is actually coming in live. So if this were the live, I probably could have shown this one, I guess, but if this were the live one, you'd be seeing this, the spectrum coming in, and you can hit your max hold, your min hold, and you can watch that spectrum stream in from anywhere, from any place you've got internet access on any device, which I'll show you here in a minute. And then we've got also a full band capture or full spectrum capture feature in here. It actually captures a snapshot of the spectrum, and you can look at any device that's full band capture compatible and check the spectrum on it. It's all the channels, and you can see if you've got any issues, like maybe this is maybe identifying tilt here, looks like. So this is, again, something nice to be able to do remotely. I mentioned that last week in TrueVision, where you can actually view live spectrum. If you've got a full band capture modem in the spectrum tab, you can view live spectrum streaming in. In this case, it's a snapshot of the last time it polled, but you can rescan at any time and get an updated scan of that downstream spectrum as well. And that's what I want to show you in the desktop application, but I also wanted to point out that there's a PNM mobile app that comes with this, which you may not be aware of, or maybe you're using it, but I think I've got that here. Yeah. So, oh, before I do that, I think I've got a question here. Let's see. Question that's not totally unrelated, okay. Quite often see if TDR 84 feet, the value is 167, is most seen. Yeah, I see what you're saying. And I think as far as the distances, they seem to be in increments. So you'll see 84, 167, and again, there's a, it's doing the best it can to calculate the distance based on the pre-EQ values and those digital taps and which ones are elevated and which ones are not. So generally, if you're seeing 84 to 167, that means it's near the home or in the home. Now you said you don't find a, let's see, no damage, kink in the line or anything. You usually find the modem may be faulty. Okay. There may be something, and if you swap out the modem, that takes care of it. That's interesting, because I wouldn't think it would do a VTDR with it, or TDR with that. But what you should check out, and I can put a link. There are a couple of links just for you and anybody else that's watching. There's a couple of links below on where I did Tech Tuesdays on PNM, on the correlation groups like I showed you, then also some in-home, near-home things, and then also on the PNM app, which I was about to show some screenshots for. So you might want to check that out. And I also did one, and I didn't post that, but I did one on using, when you have something like this with a TDR, you can use a noise, I'm trying to think of the spacing out on the word here, so you can use basically an ingress detection kind of system where you inject noise into the line, and then you have a little handheld unit, so you can just plug that in basically out at the street, wherever that is coming in from the street, and then you inject noise into the line toward the home, and then you can follow it around with this device, and you can find where there's a problem. And a lot of times that problem might be buried, so it could be, in fact, the example that we have an example where Brady Volpe is going down the driveway, and he finds a cable that was basically patched with electrical tape underneath the paving stone. So a lot of times that's what something like this would be. It's something that you can't find it. Maybe it's a piece of buried cable, or it could be maybe a bad connector or something that you don't see. So I can't say why changing out the modem would fix that. I would think maybe there's some other problem as well, and maybe changing out the modem helped. Or maybe when you were changing out the modem, it was seeing that as the 84-foot distance, and maybe when you changed it out, you tighten the connector. Sometimes just having the customer tighten the connector can fix these things. Because you know what they need to do. Or what they'll do, they'll loosen it up. They don't realize how tight it needs to be. I didn't realize that at one point. Yeah, Rick, go ahead and check that out. It's a really good, I think, summary of the app. I don't have live screens, but I'm going to show a few right now. But check that out because there's a lot you can do with that app. I just kind of run through it real quickly here. But hopefully that answered your question. And if not, we do have engineers here that you can contact your business account manager or send an email to info@zquorum.com. And I will get it over to somebody so they can call you and discuss that with you, maybe discuss some scenarios that you're looking at and give you some hints there. So again, back to the mobile app. So there's a mobile app for this, and in that, so Rick, in that other video, I explain where you get it and how to sync it up with the desktop application, because you do that basically with a little QR code. So I go through all that in that video. I don't do that here, but I'm just showing you here that we've got just the menu, of course. And then you can look at different modems, different devices. This was I guess a specific node looking at red devices, I believe. Some of the same screenshots I used last time. This is looking at a device here, so you drill in on a device and look at it, and it's the same kind of information you would get if you're looking at the desktop application as far as your values, your in-channel frequency response chart, your digital taps. So you have that same kind of information that you can pull up on a mobile device, which is real handy in the field. You've got correlation groups, so here you're seeing a device or several devices that you can see on the map that are correlated. And again, you can do the same kind of thing. So a lot of times people look at this stuff in the office and they'll go out in the field and then they'll have this in their hand as they're out there making changes or looking at things. You've got the Upstream Analyzer also that you can view on the app. And then the same thing with the downstream and the Spectra, looking at downstream issues that you can pull up in the app. So all of the stuff that, not everything I guess, but a lot of the things that are in the desktop application, you can pull up on the app, the most important things. There's also something that a lot of people I think don't take advantage of would be there's work orders in there. So you can use this as a way to, if your technicians are using the app, you can, in a desktop application, create a work order for them and it sends it right to their app. In this particular case, actually this is something else. This is another thing that you can do which might help in the future. It could help now, but if you're going to install a modem, when you're done, you can run what's called a cable installer. And I think I mentioned in the last video, it doesn't actually go out and install a modem, but this actually, that would be nice during a pandemic if you could have something go out and install a modem and not have to go in the house. But this actually runs a test of all of the RF levels and the pre-EQ values, and then it tells you at the end how it did, and it will tell you if anything failed or not, and then you can try to fix that. So the nice thing about that is if you are going to go into the home, maybe you don't have to go back the next day because you left and something was not quite right. So you can do this. You can run this cable modem installer, and it actually will then create a birth certificate, and you can look at that later. You have a record of that birth certificate. If you fix something, you can run it again and create another birth certificate, so you can see a record of those times. Again, always better to go ahead and install it right the first time so that you don't have to go back, but that's maybe especially important right now where you don't want to enter the home too much because we're trying to do the social distancing thing, and that's a good tool for that. Then you've got work orders. So you'll notice if you go into the dashboard, there's lots of places where you'll see a work order little icon, and you can click that and you can assign that to anybody who has the mobile app, and that will send it right to their mobile application, and they'll see what it is that you want them to go look at. And then they can go on the mobile app and they can check whether they've fixed it. I think they can take pictures of an issue. Maybe there's a bad piece of cable they take a picture of to document it, whatever it might be. But the work order feature in there is really very nice to be able to kind of manage things as far as who's going to work on what this time. So hope this was helpful. Again, proactive network maintenance, it's something that you can do anytime, but maybe especially beneficial right now as we're trying to be more productive in the field and also maybe touch things less. So it's good to maybe fix things now, and then if there's any issues in the future, you're really getting your cable plant in good shape. As you saw, I showed that one operator that really takes a lot of time to be proactive. If this video was helpful, I hope you will go ahead and just click like there, and if you're not already subscribed to our channel, go ahead and click the subscribe button and then ring the bell. If you ring the bell, that means that you'll get a notification anytime that we're live, and that's generally only once a week. And if we post a video, which is not that often, we're usually just doing the live videos once a week, but if we post a video, you'll see that as well. So thanks for joining me for Tech Tuesday. I'll be back here next week, same time, same location for right now, because we're all sheltering in place, and I'm assuming you are as well. And I will see you next week on a new topic. Don't know what yet, but I'll be back next Tuesday at 3 o'clock. See you then.